Good morning, girls. How are you? Okay, today we are going to be revising lesson 19.3, proving lines are parallel. We said that this lesson is the opposite of the previous lesson. In the previous lesson, we took some theorems in which it was beginning by if the lines are parallel, then whatever will happen. The corresponding angles will be equal, the alternate interior angles will be equal, the same side postulate, and these things. In this lesson, you are doing the opposite. All of our objective here is that we are trying to prove that two lines are parallel. So we are trying not to prove that the angles are equal. No, if the angles are equal, so we are trying to prove that the lines are parallel. Like what I told you, the converse of the theorem. Instead of using, for example, alternate interior angle theorem, you are going to be using the converse of alternate interior angle theorem to prove that the lines are parallel. Okay, not to waste any time, let's start in our worksheet right away. Okay, for question 1, this is question 1. Okay, so for the first question, use the figure for problems from 1 to 8. Tell whether the lines are tell whether lines M and N are parallel using the given information. And for each one from question 1 till question 8, you are given a piece of information, and using this information, we have to tell him, is line M and N parallel or no? And if they are parallel, state your reasoning. The word state your reasoning means what? Because you will find it maybe in the online test or whatever. State your reasoning means that give him the reason, like give him the name of the theorem. It's a converse of alternating interior angle theorem. It's the converse of corresponding angle theorem. It's the converse of same side interior postulate. So this is your reasoning. Why did you say they are parallel? Let's start with number 1. In question 1, he is saying if angle 7 is congruent to angle 3. Okay, I have to, let's make it bigger. And then let's see. Angle 7 and angle 3. First of all, ask yourself, angle 7 and angle 3, they form what with each other? Are they same side interior? No, same side interior will be 7 and 6, for example. Are they corresponding? No, corresponding will be like 7 and 5, for example. But they are what? They form the letter Z. As we said before, they form in here the letter Z. This is the letter Z, but it's like flipped Z. So these two angles together form a letter Z, so they are alternate interior angle theorem. And since they are equal, because he told me here that they are congruent, since they are equal, so if the alternate interior angles are equal, then lines M and N are parallel, right or not? Right. Using what? Using the converse of alternate interior angle theorem. Very good. So this is what we are going to be writing here. So here I'm going to tell him M is parallel to N using converse. Please never ever converse. Yes, don't forget the word converse, because this is what differentiates this lesson from the previous lesson. Here we are not using the theorems, we are using the converse of the theorem. Is that if the angles are equal, then the line are parallel. The theorem said if the line are parallel, then the angles are equal. So please make sure to write the word converse. So using converse of alternate interior angle theorem. Okay, very good. Now let's see question 2. Okay, let me do this in red. Okay, let's see question 2. Measure angle 3 equal 15x plus 22 and measure angle 1 equal 19x minus 10, and you are given x to be equal to 8. Of course, the first thing I should do is to substitute 8 and see what is he saying. Measure angle 3 is what and measure angle 1 is what. So this is the first thing I should do. So in the beginning, I'm going to tell him that measure angle 3 is going to be, and substitute 15 multiply 8 plus 22. The result will be, let's check our answers. So it's going to be 15 multiply 8 plus 22. So it's a 142. It's a 142. Okay, I'm going to do the same thing for measure angle 1. Measure angle 1 is going to be 19 multiply 8 minus 10. The result should be 19 multiply 8 minus 10. It's a 142 as well. So it's very obvious that they are what? They are equal, right? Let's go here and see where is 1 and 3. Where is 1 and 3? So let's first clear. And now let's see what about 1 and 3. 1 is equal to angle 3. What are those together? We have a letter F, but it's flipped F. Let's try to see it. This is the letter F. We have here the letter F. So 1 and 3 together are corresponding angles. 1 and 3 are corresponding angles. And since they are equal, so this is the definition of converse of corresponding angle theorem. Since 1 and 3 are equal, so lines M and N are parallel. Very good. So this is what I'm going to write in here. Angle 3 is equal to angle 1. So this is what we wrote. Since these two angles were equal, so I told him angle 3 is equal to angle 1, or you can put congruent sign. So M and N are parallel using what? Using the converse of corresponding angle theorem. Corresponding angle theorem. Do not forget the word converse. Okay. Let's go to question 3. Angle 7 is congruent to angle 6. Let's go and see. Angle 7 is congruent to angle 6. 7 and 6 are equal. 7 and 6 form a what? 7 and 6 together form a what? Are they corresponding? Do they form letter F, 7 and 6 together? No. Do they form the word Z, the letter Z? No. Are they exterior? No. But it's very obvious that they are same side interior angle. 7 and 6 together, they are same side interior angles. And girls, 7 and 6 or same side interior angles should be what? We said that from the 4 angles that we took, 3 are congruent and there is only one which are supplementary, which is the same side interior angle. So actually 7 and 6 shouldn't be congruent for M and N to be parallel. No, they should be supplementary. So when he tells you that 7 is equal to 6, is this a sufficient information for you to know that these two lines are parallel? No, it's not a sufficient information, because the converse of same side interior postulates say that they should be supplementary, not equal. So of course in here, for here, I'm going to tell him that M is not parallel to n. This is not a sufficient information for me to know that these two lines are parallel. Okay, very well. Let's go to question 4. You know, just like a hint before we go to number 4, angle 7 and 6 should be supplementary, right? So yeah, this is not a sufficient information, but only if something happened. You know what? If angle 7 was 90, angle 6 will be 90 because 90 plus 90 is 180. In this only case, angle 7 will be congruent to angle 6 because both of them is 90, and also both of them will be supplementary. Only in this case, M and N can be parallel. Yeah, this can be right like a note that if angle 7 and angle 6 were 90 degree, then they are equal and they are also supplementary, so line M and N can be parallel. And this is my only case, but only if he tells me 7 is equal to 6 with no other information. So this is not sufficient information for me to say that these lines are parallel. Okay, for question 4. Again, measure angle 2 equal whatever and measure angle 3 equal whatever, and x is equal to 14. So I have to find, I have to substitute first to find both measures. Right? Okay. So for angle 2, it's going to be 5 multiply 14 plus 3. And then we will find the answer. 5 multiply 14 plus 3 is a 73 degree. Then let's do the same thing for angle 3. Angle 3 is going to be 8 multiply 14 minus 5. The result will be 8 multiply 14 minus 5. The result is 107. It's very obvious they are not equal. But let's check angle 2 and angle 3. They form what together? Angle 2 and angle 3. They are just like 7 and 6. So they form a same side interior angle. Same side interior angle should be what? Should be supplementary, right? Let's check. This is what we are going to check. 107 plus 73. Does it give us 180? Let's check. 107 plus 73 is actually 180. They are actually 180. So I can say that angle 2 and angle 3 are supplementary. They are supplementary. So M will be parallel to N using which theorem? Converse of same side interior postulate. Right? Okay, very well. So this should be in here, you understand? This is like in here, okay? Okay, let's go to question 5. Actually, I'm going to leave question 5 for you because it is the same idea. You have angle 8, you have angle 4, you are going to substitute and then check. Here he is saying angle 8 and 4. Let's check where is 8 and 4. 8 and 4. 8 and 4 are what? 8 and 4 are alternate exterior. And alternate exterior should be what? Should be equal, right? So if they are equal, you are going to say they are parallel. If they are not equal, they are not parallel, right? Okay, so let's go to question 6. Angle 5 is congruent to angle 7. Angle 5 is congruent to angle 7. What do you think? 5 and 7, they form a what? They form the letter F. It's very obvious F here. Since they are congruent, so those are congruent corresponding angles. So of course the lines are going to be parallel. So this is what you are going to be writing in question 6. In question 6, we are going to write that M is parallel to N using converse. Please do not forget the word converse. Converse of corresponding angle theorem. And then angle 1 is congruent to angle 5. 1 is equal to 5. If 1 is equal to 5, so this is what? 1 and 5 are, 1 and 5 together, guys, are alternate exterior. They are the same as alternate interior, but they are outside. That's why they are called alternate exterior, and alternate exterior should be equal. So actually here M will be parallel to N using converse of alternate interior, no, sorry, alternate exterior this time, alternate exterior angle theorem. And then measure angle 6 equal x plus 10 and measure angle 2 equal x plus 15 with no values of x. So there is no substitution to do. Okay, so what should we do? It's very obvious that since this is x plus 10 and this is x plus 15, so angle 2 is not equal to angle 6, right? This is x and yani as if we are comparing x, x. So they are equal. Plus, plus, again equal. And then 10 and 15. So are the two angles equal? They are not equal. So let's go up and see. Angle 2 and angle 6 are what? Angle 2 and angle 6 are what? They form letter Z. So they are alternate interior. And alternate interior should be what? Should be equal to make the lines parallel. Since they are not equal, so the two lines are not parallel. So M is not parallel to N. Of course, M is not parallel to N. Okay, very well. In here, we explored from question 1 to number 8, we explored all the kinds of converse theorems. Now we are going to the proof questions. We have to prove questions and that's it. We are just going to prove some questions and that's it. Okay, starting with question 2, write a 2-column proof. Given that angle 1 and angle 3 are supplementary, okay, we have to increase this shape a little bit just to see. Angle 1 and angle 3 are supplementary. It's given that angle 1 and angle 3 are supplementary, which means if I add them, this will give me a 180 degree. We are required to prove that HI is parallel to JK. Yani this line is parallel to this line. First of all, angle 1 and angle 3, do they form any kind of angle together? Actually, they don't. Angle 1 and angle 3, they form nothing together. They are neither alternate interior, alternate exterior, they are not corresponding, they are not same side, they are nothing. So they are going to help me to find another pair of angles, which are going to be one of the 4 angles that we said. Let's think together. Here he is giving you a hint about angle 2. He's saying that this is angle 2. So of course we are going to be using angle 2. To prove that the two lines are congruent, or parallel, sorry. To prove that the two lines are parallel. Don't you think that we should prove that 2 and 3 together are what? Angle 2 and angle 3 together, they are corresponding, they form the letter F. So if I prove that angle 2 and angle 3 are equal, so I will be able to say that these two lines are parallel using the corresponding of, using the converse of corresponding angle theorem. If I prove that 2 and 3 are equal. So again, 1 and 3 will not help me to prove that the lines are parallel because they form nothing together. But angle 2 and 3, they form a corresponding angles. If I prove that 2 and 3 are equal, so I can say that these two lines are parallel using converse of corresponding theorem. How can I prove it? 1 and 2 together, girls, they form a what? 1 and 2 together, they are linear pair, which means that they are supplementary, which means that 1 plus 2 is 180. And he told me that 1 and 3 are supplementary, which means 1 plus 3 is 180. So here you have two equations. 1 plus 2 is 180, and 1 plus 3 is 180. By substitution and removing 1, yeah, since 1 plus 3 is 180, and 2 plus 3 is 180, we can say that actually 2 will be equal to 3. 2 will be equal to 3, right? So let's begin writing together. First of all, the first statement should be the given. So angle 1 and angle 3 are supplementary. Why? Because this is given. And then let's explain the meaning of supplementary. It means that angle 1 or measure angle 1 plus measure angle 3 is equal to 180. Why? Because this is the definition of supplementary. This is the definition of supplementary. And then angle 1 and angle 2 are supplementary as well. Why? Because they are linear pair. So here I'm going to tell him that angle 1 and angle 2 are supplementary. Why? Because of the linear pair theorem, which means that measure angle 1 plus measure angle 2 will be 180, which is the definition of supplementary. Very well. And then let's use the transitive property. Using the transitive property in both here and here, we can write that measure angle 2 is equal to measure angle 3, right? Transitive property, or you can say it's like substitution property of equality. And then I can write, since these two angles are equal, so HI is parallel to JK using the converse of corresponding angle theorem. And that's it. You know that you can do it in even easier ways. Yani you can do it in less statements that I did. Instead of the supplementary, because of the linear pair, you could have written this here right away. Angle 1 plus measure angle 2 equal 180, because this is linear pair. Even the proof thing can be done in many ways, not only one way. Okay, question 3. Let's go to question 3. Write a two-column proof of the converse of the alternate interior angle theorem. Write a two-column proof of the converse of the alternate interior angle theorem. Yani given that lines L and M, this is M, are cut by the transversal T, and angle 1 is congruent to angle 2. You are given that angle 1 is congruent to angle 2. Prove that L is parallel to M. Of course, this 11 thingy here is nothing. So prove that L is parallel to M. Prove that L is parallel to M. Okay. Before you ask teacher, 1 and 2 are equal, so this is the alternate interior angle theorem, so this is already equal. I know they are already parallel, but here we are trying to prove the theorem. Didn't I tell you before there is a difference between postulate and theorem? Theorem should be proved, but postulate shouldn't. So we are going to prove the theorem using the postulate, which means I have to prove the theorem using the same side interior postulate. So let's think together. He is telling me that angle 1 is congruent to angle 2. Okay, let's think together. Angle 2 and 3 together are what? They are linear pair. Angle 2 and 3 together, they are linear pair, right? So 2 plus 3 is 180. 2 plus 3 is 180. Very well. Since 2 is equal to 1, so using substitution property, 1 plus 3 will be equal to 180, right? Which means 1 and 3 are supplementary. Since 1 and 3 are supplementary, so I can say that these are the converse of the same side interior postulate, so line L and M are going to be parallel. Let's write this together. So first of all, lines L, and actually I don't need to write this. I will begin by angle 1 is congruent to angle 2 because this is given. And then angle 2 plus angle 3, or angle 2 and angle 3 are supplementary. Why? Because they are linear pair theorem. So angle 2 plus angle 3 equal to 180, because this is the definition of supplementary. And then using substitution method, I will remove 2 from here and put 1 instead. So angle 1 plus angle 3 equal to 180. What did I do? I used substitution property. Substitution. I think there is a T missing. Okay, substitution property of equality. And then, since they are equal to 180, so we can say that angle 1 and angle 3 are supplementary. I can tell him that again, this is the definition of supplementary. And then, since they are supplementary, so L will be parallel to M using the converse of same side interior interior postulate. Since you reached a postulate, so your theorem is correct. We are trying to prove the theorem, so we have to reach a postulate at the end, because postulate, after the postulate, there is nothing. This is your proof. Okay, very well. So we finished lesson 19.3. I hope it was easy. If you have any problems, tomorrow we'll be having our online Zoom lesson, inshallah. We will be revising tomorrow, I think, lesson 19.4 and maybe lesson 19.5 as well, both lessons together. And by the way, girls, you will be having another, or your last online assessment about lesson 19.4 tomorrow, inshallah. This will be your last online assessment. So try to prepare the lesson from today. Okay, thank you and see you tomorrow, inshallah.